Good morning, dear children. Now, today we will discuss with the new point of the same chapter, cell. Now, cell, this is the diagram of a cell, and this one is the open circuit, the cell in which the external circuit is not connected, and this is a cell in which the external circuit is connected. Okay. Now, the cell is a device which maintains the necessary potential difference for the continuous flow of electric current. Now this cell will make the current to flow, and it is a source of electric current. And in this cell, they maintains the continuous potential difference for the continuous flow of electric current. Now, the next point that is related with the cell is the open circuit and the closed circuit. Now, as you know that circuit is it is a path in which the current flows. Now, when you see this, follow this diagram, the two diagrams I've drawn here. This represents the open circuit, the first one. Second one is the closed circuit. Now, the open circuit, let us discuss first the open circuit. When the terminal of the cell means this one, negative and positive, these two terminals. When this terminal of the cell is not connected to the external circuit, no current is drawn from it, and the circuit is said to be as an open circuit. So, in an open circuit, there is no flow of current, since the cell is not connected with the external circuit. So you can see here the cell is not the two terminals of the cell is not connected with the external circuit. So no current is drawn, and this is an open circuit. Second one, when the terminal of the cell is now connected with the external circuit, when the terminal of the cell is connected with the external circuit, now the current will flow, and the circuit is said to be as a closed circuit. So in a closed circuit, the current flows, and in open circuit, the current cannot flows. Now, the next point again. Now again follow the same here, the same diagram. Open circuit. Now in open circuit, now how these the cells, now how the electrode. Now in a cell there are the electrode and the electrolyte. Okay, now this cell consists of, when we go to the construction of the cell, okay, now the cell consists of two electrodes, okay, or the two dissimilar metal plates, and this metal plate is known as electrode, E-L-E-C-T-R-O-D-E, yes, electrodes, and the two electrodes are there, copper and zinc, and these are the two metal plates which are immersed in a liquid that is dilute sulfuric acid, and this liquid is electrolyte, E-L-E-C-T-R-O-L-Y-T-E, electrolyte. So the cell consists of electrodes and electrolyte, and this electrode is immersed in electrolyte. When they are placed in electrolyte here, the chemical action of the metal plate and the electrolyte, the electrode and the electrolyte, we will say, this chemical action of electrode and electrolyte will make the two electrode charged. Okay, so the copper and the zinc, since they are the two electrode, and this copper will become positively charged and the zinc will become negatively charged, and these charged electrodes will be formed due to the chemical action of the electrode and the electrolyte. So they will form a two charged electrode. Okay, so copper will become positive electrode and the zinc will become negative electrode. Now this electrode has to be separated. Okay, this electrode has to be separate. That means the negative and positive electrode has to be separate, and they need some energy. And this energy is supplied by the electrolyte. Okay, this energy is supplied by the electrolyte, and the energy which the electrolyte provide, this energy will separate the two electrode into the two ends, into the two terminals. Okay, so when they get separate, okay, and now the potential, the necessary potential difference will be developed within the electrode. So within this electrode, the necessary potential difference will be developed, and the potential difference will be developed even though the cell is not connected with the external circuit. That means in open circuit. In open circuit, even though there is no flow of current, but the potential difference between the two electrodes will be exist there, and this potential difference between the two electrodes in an open circuit where no current is drawn from it, we call it as EMF, or known as the electromotive force. So this electromotive force are produced in a cell, and these are produced between the electrode. Okay, between the electromotive force will be produced there. Okay, so I have written here E. This is EMF, which is EMF can be symbolized as E. Okay, and this EMF will be exist within the electrode, within the two terminals of the electrode when the current is not drawn, or in an open circuit we call it as EMF. So therefore, when we define EMF, it is the maximum potential difference between the two ends of the electrode in an open circuit is called the EMF, or the electromotive force. Okay, and there are two factors on which the EMF depends. Number one factor is the nature of the material of electrode. Okay, what kind of electrodes is made up of? Okay, either now the two electrodes are here, they are made of copper and zinc. So other than that, they can be other metal also. Okay, so number one factor is the material of the electrode, and other one is the electrolyte used in the cell. Two factors are there. Electrolyte used in the cell. Here the electrolyte used is dilute sulfuric acid, but the other electrolyte can also be used. Okay, so depending upon the two factors, the EMF depends, and the EMF, the potential difference can be maximum or minimum depending upon the electrode which are used in the cell as well as the electrolyte used. Okay, so these are the two factors. Now let us come to the next point, that is a closed circuit. Open circuit, EMF will be developed there. Okay, maximum potential difference. Now these two terminal of the cell is now connected with the external circuit. You can see this external circuit. Now when the external circuit when it is connected with the external circuit, now the current will flow from positive to negative. Okay, and as well as the potential difference will be maintained, and the potential difference between the two electrode, when the electrode are connected with the external circuit, or the cell are connected with the external circuit, so that potential difference we call it as a terminal potential difference, or the terminal voltage. So next point will come to the terminal potential difference and terminal voltage. Okay, so this one is terminal potential difference. Terminal potential difference, or we call it as a terminal voltage. Terminal voltage. Okay, so now this terminal voltage is the potential difference between the two electrodes in a closed circuit. Okay, when the current flows, there is a between the two electrodes there exists a potential difference in a closed circuit, that we call it as a terminal voltage, or the terminal potential difference. Now the next point is here. Now when the current will flow, okay, now the potential difference is maintained, we call it as a terminal potential difference. Now when the current will flow through the external circuit, the voltmeter reading drops. When the current flows to the external circuit, there is a voltmeter, and voltmeter is an instrument to measure the potential difference. So when the current flows to the external circuit through the cell, the voltmeter reading it drops. That means it becomes zero. Totally it drops. So when the voltmeter reading it drops, then this is known as the voltage drop. So the next point is the voltage drop. So voltage drop is also taking place in a closed circuit. In open circuit, only EMF will be developed within the electrode. Okay, but in a closed circuit, terminal potential difference or terminal voltage as well as voltage drop will be formed. So voltage drop will be there when the voltmeter reading it drops abruptly. Okay, as well as when the current is flowing through it. So this is known as the voltage drop. And this voltage drop, the reason for the voltage drop is because of the resistance offered by the electrolyte of the cell. So the electrolyte means dilute sulfuric acid. So electrolyte will offer some resistance, okay, and this resistance will make the potential difference to drop, okay, and this drop of potential difference can be measured with the help of voltmeter, which has been joined with the external circuit here. So when there is a drop in a potential difference, we call it as a voltage drop, and this voltage drop is due to the resistance offered by the electrolyte, and that resistance offered by the electrolyte of the cell we call it as internal resistance, which is written as small letter r. Capital letter R is the external resistance, which is offered by the wire, by the external circuit. Okay, but this internal resistance is offered by the cell. So this, due to the internal resistance offered by the electrolyte of the cell, the voltmeter reading drops accurately, and therefore the voltage drops will take place. Okay, so this is about the internal resistance, and let us come to the definition of internal resistance. So the next point is the definition of internal resistance. Now the internal resistance is the resistance offered by the electrolyte of a cell, okay, in a closed circuit is known as the internal resistance. Okay, so the resistance offered by the electrolyte of the cell, which in the flow of electric current, is known as the internal resistance, which is denoted as small letter r. So this is internal resistance, and there are certain factors of internal resistance. Number one factor of internal resistance is the internal resistance is inversely proportional to the area, cross-sectional area of the electrode. That means the surface area of the electrode. Number one factor is there. The surface area. Number one factor in which the internal resistance depend is the area of the electrode in contact with the electrolyte. Area of the electrode in contact with the electrolyte. Because these electrodes are in contact with the electrode. Since they are deep inside the electrolyte, so number one factor is the area of the electrode in contact with the electrolyte. So number one is here internal resistance is inversely proportional to the area of the electrode. So now from here, larger the area of the electrode, larger the area of the electrode means if I make this the cross-sectional area of electrode bigger, okay, like this, bigger. In both the cases, I make the cross-sectional area of the electrolyte bigger. So when the cross-section area or the surface area, you say the surface area, the cross-section area, the surface area of the, if the surface area of the electrode is larger, then the internal resistance will be smaller, because since they are inversely proportional. If the area is larger, if the surface area of the electrode is larger, internal resistance will be smaller. If the surface area of the electrode is smaller, then the internal resistance will be more. Okay, or it becomes larger. So the first condition is there. So suppose if I make the area of the electrode larger, then what will happen is that the internal resistance will become less. Now, why the internal resistance becomes less is that because since the internal resistance is provided by the electrolyte. Remember, it's very important here. The internal resistance is provided by the electrolyte of the cell. So, when the surface area of the electrode becomes larger, then what will happen? The flow of electrons takes place. Okay, flow of electrons takes place without any resistance. Okay, and therefore what will happen is that the potential difference will not fall. Is it clear? So that means the internal resistance will become less. Since why the internal resistance become less is that because the surface area is larger and the flow of electrons will takes place much more weaker. So last time I have told you, longer the wire, more will be the resistance, because they have to travel a long distance from one terminal end of the conductor towards the another end. So on the way they get collide with the neighboring electrons or with the positive charge ions, and therefore that finally makes the obstructions of the flow of current, which provide resistance. So shorter the wire, lesser will be the resistance, like that. The same like that, if the surface area is more, then the distance between the two electrodes will become less, and therefore the internal resistance become less. Okay. And the next one is if the electrode is thinner. Okay, if the electrode is small, you say if you take a small, if the surface area of the electrode is small. Okay, here also if I take the surface area of the electrode small. So what will happen here? This distance will increase. That means when the distance will increase, internal resistance will increase here. Okay, internal resistance will increase. So therefore, if you take the electrode, if you take a surface area of the electrode smaller, then the internal resistance will be less. If you take the surface area of the electrode larger, then the internal resistance will be more. So if the internal resistance will be more, what will happen? There will be the obstruction in the flow of current, and finally the voltmeter reading drops, and that finally causes the voltage drop. Okay, and the next factor is internal resistance is directly proportional to the distance of the electrode. Directly proportional to the distance of the electrode. So that means if the distance between the two electrodes will become more, will increase, the resistance will also increase. If the distance between the two electrodes decrease, the internal resistance will also decrease. So same like that of the surface area. Okay, so more the surface area of the electrode, lesser will be the internal resistance. But they are inversely proportional. But since here the internal resistance is directly proportional to the distance. So if the distance increases, internal resistance will also increase. If the distance decreases, internal resistance will also decrease. So when you increase the distance between the electrode, the internal resistance increase. When you bring the electrode closer, when the distance between the two electrodes you decrease, then the internal resistance will also decrease. So this is the second condition. And third one is here, nature and concentration of the electrolyte. What kind of electrolyte you will use? Okay, so internal resistance is directly proportional to the nature of the electrolyte. Nature of electrolyte. electrolyte. Electrolyte means this sulfuric acid. Nature of the electrolyte. So that means they are directly proportional. That means the concentration of the electrode. If the concentration of the electrolyte is more, then internal resistance will also be more. If the concentration of the electrolyte is less, internal resistance is also less. So that is why, in order to provide less internal resistance, the electrolyte used in the cell is dilute sulfuric acid. This is one of the reasons why dilute sulfuric acid is used. You can use concentrated sulfuric acid also, because if you use concentrated sulfuric acid, internal resistance will become more. So when the internal resistance will become more, the current flowing through the external circuit will get obstructed, because the potential difference will drop due to the internal resistance provided by the electrolyte. Okay, and if the current cannot flow, okay, and there will finally be the voltage drop. Okay, so that is why dilute sulfuric acid is used. So therefore, nature of the electrolyte. Higher the concentration of the electrolyte, more will be the internal resistance. Lower the concentration of the electrolyte, lesser will be the internal resistance. So this is number 3. And number 4, the last one is the temperature of the electrolyte. Internal resistance is directly proportional to the temperature of the electrolyte. Higher the temperature of the electrolyte, more will be the internal resistance. Lower the temperature of the electrolyte, lesser will be the internal resistance. So these are the factors. Okay, these are the 4 factors in which the internal resistance of the cell it depends. And this internal resistance is provided within the cell. That is, this is provided by the electrolyte. Okay, and between the 2 electrodes, the terminal potential difference is maintained when there is no flow of current. So these are the terms related with the cell. Thank you.